and today we are going to talk about digital twin. So what is a digital twin? A digital twin is defined as a virtual representation of an object or system. So let's see what we have got for today's presentation. Today we would be classifying the digital twins, the types of digital twins, application of digital twins, the market share and the analysis, and the designing part of the digital twin. So let's move forward. So what is a digital twin? As I already mentioned, a digital twin is defined as a virtual representation of an object or system. The digital twin's life cycle is from updating real-time data and then uses simulation, machine learning, and reasoning to assist in decision making. For example, if a machine in a workshop needs to be twinned, so what are the processes and what is the exact feature? A machine is fitted with sensors that monitor the machine's working and then produces data about its working. This data is then forwarded to a processing system. The processing system makes a digital copy with similar attributes and applies the input. Once it gains the information, it studies performance issues. It generates possible improvements to create values, insights, and then uses it back to the original machine for the progress and better result. So it basically comprises of IoT, that is the Internet of Things, that is the data center, which grabs all the aspects and the data from the machine learning that integrates the data and makes a digital copy of the real machine, and the simulation that is used for testing and understanding the real life processes. Moving forward, let's see the classifications of digital twin. The digital twin can be classified into 4 levels: parts twinning, asset twinning or the product twinning, system twinning, and process twinning. So the part twinning is the process in which the virtual representation of the individual factors give the capability of understanding the physical, mechanical, and electrical characteristics. The product twinning is the system integrator that the parts as they work together to make a product in a digital form. Moreover, the system twinning allows the working engineers to operate and maintain entire lines of distant products that work together to achieve a result at a system position. The process twinning. The process twinning empowers the optimization of the operations involved in enhancing the raw stock or product of finished goods. So let's take an example and make it clear for you all. Suppose we have to make a digital twin of the working of a car factory. There are several units with various parts for making the vehicle in a car factory. The twinning of the entire factory working is carried by the process twinning, which twins the whole working of the factory. There are various units in the car factory like engine making unit, body house, painting department, etc. The twinning of every team separately would be done under the system twinning. Moreover, the machines running in each unit would be twinned and tagged under the product twinning. Further, the smaller parts of the machines would be twinned under the parts twinning. In this way, the entire procedure of twinning is done, and the whole project is covered in tiny bits, accounting for a huge amount of work. Let's see the case study for the Boeing digital twin. At Boeing, the digital twins are used to plan aircrafts. A digital twin is created for a new airplane, after which simulations are run that predicts the versions of various airline elements over the product lifecycle. As a result, Boeing engineers can forecast when products are expected to fail. The company has achieved a 40% enhancement rate in the first time quality of parts by using a digital twin. The company plans to digitize all of its engineering and development systems in the future and share this information with its supply chain. Now, let's see the market analysis or the growth of the market for digital twin. The global digital twin demand size was valued at 5.04 billion in 2020. It's expected to expand at a CAGR, that is the compound annual growth rate, of 45.56 billion from 2021 to 26. The demand witnessed a slight recession in 2020 owing to the shutting down of manufacturing places, production factories, and other plants in the first half of the cycle triggered by the spread of COVID-19 pandemic. However, owing to the varied operations of digital twin, the demand is strengthened for exponential growth. now let's see why should we use a digital twin. The use of digital twin enables further effective research and design of products within an abundance of data created about likely performance issues. That information can lead to insights that help companies make needed product advancements before starting a product's production. Even if a new product has gone into effect, digital twin can help reflect and watch production systems to achieve and maintain peak effectiveness throughout the entire manufacturing process. Required updates and timely modification can also be done with the digital twin. Further issues can also be determined using the behavior of this input. Now, talking about the designing part. So a digital twin is made up by gathering data and creating models of exact characteristics to test it. A digital twin requires data about an objective or process to create a virtual miniature that can define the behaviors or states of the real-world item or procedure. This data may relate to product's life cycle and include design specifications, product processes, or engineering information. It can also include product information, including outfit, corridor, style, and quality controls. Once the data has been gathered, it can be used to produce computational analytical model to show operating effects, predict states such as exhaustion, and determine its behaviors. These models can behave based on the engineering simulation, physics, statistics, engine, knowledge, artificial intelligence, business logic, or intentions. These models can be displayed via 3D representation and augmented reality modeling to help humans understand the finding. The findings from the digital twins can be linked to produce an overview similar as by taking the results of equipment twins and putting them into a production line twin, which can again inform a manufacturing scale digital twin. Using linked digital twins in this way makes it possible to enable intelligent artificial operations for real-world operational, developmental, and advancements. Thank you.